Everybody knows.
All systems of equation with elimination, you probably already know it. You might just be a little rusty on it. Don't really see it a lot in geometry, but it's been a while since you've been in algebra. Definitely cover that in like algebra 1. Okay, so first off, for elimination, and this is everybody's favorite method because it is, I think, a little easier than substitution. Get a little technical here. We need coefficients. My sloppy handwriting there. Now remember, coefficients are the numbers in front of the variable that differ only in sign. So you want like a positive 5x and a negative 5x. And how we get this to happen is, of course, by multiplying all terms of one or both equations. Remember, you do not have to multiply both equations. You may only need to multiply one equation. We are looking for a 10x and a negative 10x. Whatever I have to do to make that happen. Okay, once we've done that, we are going to add the equations to eliminate. That's why it's called elimination. One variable and solve the resulting equation. Now, just like you did on substitution, once you have an answer, you know x is 7. You're going to back substitute the value obtained from step 1 into either of the original equations. And I put number 4 on for fun because I'm 100% sure nobody's going to do it. Check your solution. Way to own it. we should check. Now, if we're on our quiz or test and maybe we're a little sketchy, we're like, oh gosh, should I screw a sign up or something? Plugging it back in to double check that it is correct is very easy on your calculator. Might be worth doing. Just throwing it out there. All right, solve the following using elimination. Now, remember, you have to be proficient at all the methods. Meaning, on your quiz Thursday, I'm losing track of days when we're off a day. There's going to be some problems that say you have to solve by substitution. There will be some that say you have to solve using your graphing calculator. And then there'll be a set that says you can use elimination. There'll be some you can pick your poison on and solve it however you want. Okay, solve the system. Well, probably the easiest, I would get the y's to eliminate because all we have to do is multiply this one by a 3, and then our negative 3y and 3 will cancel. So I'm going to multiply that whole equation by 3. That's a parenthesis there. I'm just going to stack them underneath again and make it look pretty. I like it, you know, to look nice. So I left the top equation, and I'm distributing 3 through the bottom. And remember, we're going to add the equations together. So 2x plus 9x, or really I just think of it, you combine the like terms. Y's are out, and x, negative 2. Now, we need y, of course. Pick any equation up there that you want. I'm going to pick the very top original one just because I have room kind of to write by it. If I put negative 2 in there for x, I'm going to have 2 times negative 2. And then I'm just going to finish solving that for y. I'm going to add 4 over. And of course, y is 1. Now, I don't care if you leave the answers just like that. If you like to write them ordered pair style, get wild and do it. Does this, I hope, look vaguely familiar?
8th grade.
I know. This is, yeah. So I have a feeling you're probably going to get ahead of me and blast through the front page. Okay, you pick on B. Do you want to eliminate x or y? I hear both. Kind of how I decide. 5 and 2, I could make them 10s. 3 and 4, I could go 12. Usually I try to pick the smaller number, but I mean 10 and 12 are really pretty close. Really doesn't matter in this case. I heard y first, so let's go with that. So I'm going to times this one by 4, so I get a 12y. 3, so I get a negative 12y. Let's multiply. 4 times 5, 4 times 3, 4 times 9. 3 times 2, 3 times negative 4. And what's 3 times 14?
It's 42.
Perfect. Okay, remember we add them. I mean, you know, you combine the like terms, really. So we're going to have 26x, 36 plus 42. Mental math it. What do you got? You can mental math it.
He's so for real.
X is 3.
Oh my gosh.
Okay. Pick any equation your little heart desires that's up here. I always go back to the original just because they're smaller numbers, and I'm going to put 3 in for x. I'm going to do this bottom one because I'm like 2 times 3, that's going to be easy, 6. I'm going to subtract 6 off. 14 minus 6, 8. So we get -2. And again, I don't care if you leave the answers like that or write them ordered pair style. All right, let's do the next one. I'm questioning, well, it's kind of fun. Sorry to hear some mumbling.
This doesn't work.
Sorry to hear some mumblings. It sounds like we times this one by 2 and we realized everything would cancel, right?
Is it no solution?
Just let me write it. Let me write it.
Well, I'm right, so you're also right.
Oh, 1. I might help if I write this right. That's a 1. Okay, so you added them up. Technically, what do you have on the left-hand side? On the right.
Chicken egg.
The 0 equals 7.
No, it's no solution.
No solution. So what does this mean? What would the graph look like?
They wouldn't intersect.
They wouldn't intersect. Now, pro tip, I could have told you that before I even wrote anything.
Oh, so why did you just tell us that in the first place?
Can you tell without work?
Nope. One's negative, one's positive.
Because really, the left sides, aren't really the left sides the same, like 2/4, 1/2, 3/6, it's all the same darn thing, right? If you reduce this by 2.
Oh.
But the right sides equal different numbers. So how are you going to have 2 left sides being technically the same? If you divide that by -2, it's the same, but they equal different numbers. I saw that right away. I was like, oh, no solution, I'm done. I can do this one in my head.
It's 0. It's no solution.
Wait, how did she say
It's all solutions.
You have 0 equals 0, which means what?
All solutions.
All solutions. I could tell you that in my head. Why?
Because it equals 0.
Divide the bottom one by 2, and aren't they technically the same equation? So the same line touching the same line, they touch everywhere. I don't even do work for these. I'm like, oh, and then I'm done. So,
what is that?
infinitely many solutions.
Oh, yeah,
Have you heard that phrase?
I
heard you kind of saying all solutions, which
Eighth grader, I remember that.
is the baby form of it.
Yes, I do.
All right, questions on that? All right, now you pick. Use any method. What do you want to use on A? Elimination, and I probably just run a negative through one of the equations, right? So I'm just going to do the bottom.
Look at that.
Oh, man.
What's 17 times 4?
That is too much work.
Well, that's why I have a calculator.
All right, what do we have for x? X equals...
Oh.
I got it.
Now, I just ran a negative through one of the equations to get a 3y to cancel with the negative 3y. Work smarter, not harder here, people.
It's y equals 5.
And let's plug it in. I'm going to do the top one. -2. You have the double negative, so 2. And most of you can solve that in your head. Subtract 2, you'll be down to 15. And we do get 5. So we're already solved for y. I'm just going to substitute it in.
Boom. We're done. Almost done, Courtney.
I know, this is an easy one today. I think. I feel as though I've taught you absolutely nothing new. Just a refresher maybe.
So when we get to the end.
What does difference mean in math?
This is my answer.
Subtract. So x minus y.
Just tell me it's not working.
So there's our equations. Clearly, let's be smart here. Are you using substitution or elimination? Elimination, because y's are ready to cancel for us. Let's just get rid of them.
I'm literally running. And it took me a lot less work than that.
So x is
12. It's not right. 12. No, I did it wrong. I did it wrong. I did it.
Thank you, Owen.
Wait,
I'm glad
is
you're here.
it 22 and 12?
22 and
Okay,
12.
then I did it right, Courtney.
So what's y?
I just did it
12.
I did it a different way and got the same answer.
Because they have to add to 34. Okay, Avery, not to like pick you out, I'm just curious, what did you do for it?
I did x plus 10 equals 34.
Oh, so you kind of did substitution.
Yeah.
I gotcha.
But I just didn't
That's
use
fine.
a y.
That's fine. So just, no, I'm not picking on that. Just be careful though, okay? Because this is a direction thing. And notice it says write a system of equations and solve. So I need, so you did the y equals, what did you, x plus 10, right?
Yeah.
And then you technically substituted this in, which is totally
I
fine.
just didn't write it.
But you need to write it on a quiz or test, is what I'm telling you. All right, let's do, I don't know why I picked a gas station problem, but here we are. Okay, gas station sells regular gas for $2.20 a gallon. Who's selling gas for $2.20
I'm
this
trying to
day?
get their
And
gas.
$3.
Really, Avery? I can't
I'm
End
gonna
of the
get their
business day,
premium gas.
$280. Here we go, people. Alex, keep it together, everybody. Okay, we total of $680 spent. How many types of gallons of gas have been sold? So remember, this is kind of like those interest money problems, meaning keep the similar things together. I'm going to keep the dollar amounts together in one equation, and I'm going to total the different types to the total amount of gallons sold for my other equation. I'm going to do the dollar ones first. So $2.20 is one type of gas, our premium gas. I'm just going to let X be the premium gas, and then $3, or the regular gas, and $3. I don't know why I'm putting the decimal places. I probably would just do 3. And $680. So keep your dollar amounts together. Now, next equation, bless you. We sold at the end of the day a total of 280 gallons. So your regular gas, your premium, a total of 280. And then of course you could pick your poison, substitution or elimination. What are you thinking on this one?
Elim.
Okay, you want to get rid of probably y, I'm guessing?
Yeah.
Because let's just run a -3 through this. So I got my 220x. I can't keep writing that 3.00y, it irritates me. I'm just going to put 3y. And I'm going to multiply by -3 here. Okay, -3 times 280. Add them up, 220 minus 3, -0.8. We got -160 over there. Divide it out, what do you have for x? X equals, and I'll punch it in.
X equals.
X equals.
200.
Thank you. Okay, let's label though. Label, word problems label. That's 200 what? Gallons of regular gas.
I was just thinking, yeah.
Okay. Mental math for me. What's y?
80.
80, because we need a total of 280. So we sold 80 gallons of premium.
These are what I'm really good at. This is like miles.
I don't think these are bad for word problems. Lord knows we've done worse word problems. I don't think these are too bad. All right, last one. Ready? Okay, final one. So a woman keeps fit by cycling and running every day. Really, this is about me. Okay. On Monday, she spends half hour each activity, covering a total of 12.5 miles. Tuesday, she runs for 12 minutes, cycles 45 minutes, covering 16 miles. Okay, right away, I do not like that we're in different units. Because Monday, she's doing a half hour Tuesday, she's in minutes. So we're going to have to do some converting. Not that that's the end of the world, but whatever. Assuming her running and cycling speeds don't change, find the speeds. Okay, so let's write an equation for Monday and one for Tuesday. So first question, do you want to work in minutes or hours? Okay, so on Monday, half hour, 30 minutes. Now each activity. So I'm just going to let X be one of the activities at each activity, so the other one is also 30 minutes. She did an equal split, and she did a total of 12.5 miles. And I'm going to do really the same type of equation, but for Tuesday. So Tuesday, she ran for 12 minutes and cycled for 45 and covered a total of 16. Okay, so you pick. What are you thinking? Substitution or elimination? They're kind of bad numbers, aren't they?
Yeah.
I don't know who would do this.
I don't know who would do this to us. You could try to reduce them. You're going to have some decimals or something at some point in there that you just really can't get rid of. I hear you guys calculate. I'm going to see what you come up with.
Cut this and
Maybe not.
then this times this by 3, negative 3.
I hear the calculations happening.
I'm not using
What is-
that. No, I'm waiting for somebody.
I got it.
Come on. Oh,
I got
I'm
it.
waiting for somebody else to get an answer, is
Miss
what
Farr, I got
Owen
it.
just said.
I got it.
Oh. See?
Let's do it.
I'm waiting for somebody else.
No.
I got it.
Where's the grit, Owen? Where's the grit?
Not here.
Why don't you ask, well, be nice to Riley maybe and ask him what he got.
Please, Lord and Savior Riley.
Alright, Riley, what do you got?
I got 20 miles per hour. Oh, I did it per hour though.
Okay, I don't
So
care.
20 miles per hour biking and
Okay.
5 miles per hour running.
I like it. So he did it in miles per hour.
Dude, this was not even my final answer. This is like half a step.
My handwriting is really just getting worse by the year, I swear. Now, he was in miles per hour. What if you were in minutes? Did you, those that worked in minutes?
Is it 0.0833 repeating?
That's what I It's in hours, you're going to minutes.
So you would have to convert it. Do I care which style you give me, the mile per hour, the mile per minute?
Is that the
No, that's fine. But just to show you, if you did it in hours, this is what I'm guessing Riley's equation was.
It was with fractions.
Yep. And then 12 over 60, you gotta see, I got a sheet. 12 over 60 is 0.2. 45 is 0.75. So that would be if you're in hours. Do I care which word you give it? No, it doesn't say. You could give whatever you want. So just because Riley actually did the work and didn't just wait for somebody to give the answer, I'm going to give the hour equations here. Owen? All right. Any questions, though, on the word problem or the equations? That's the hard part of writing them.
No.
No, of course not. Okay. Let me